So we are looking at this question. The ball is dropped from a height of 65 meters above the ground. Calculate the velocity of the ball just before it strikes the ground. Take G as 10 meters per second squared. This is a case of a motion of a body under gravity in the absence of air resistance or with air resistance negligible. So we are given the initial speed of we take the initial velocity of the stone of the ball as 0 because this ball falls from rest from a height of 65 meters above the ground. Now we are going to take G as 10 meters per second squared. It's given already, and we need to find the speed of the stone of the ball just before it strikes the ground. So we have four parameters: U, H, G, and V. We go through the equations of motion, and then we identify that particular equation that has these four parameters: the initial speed, the height of the stone above the ground, the G value, and the final speed. The time is not considered here. That is, we are not asked to find time. So we are going to ignore the equations that have time. So we go to equation 3, which is V squared equals U squared plus 2GH. Why do we use positive for both speed and acceleration? You recall from my last video session that I took the direction downwards as positive because gravity acts in that direction. So since the body falls downward, the speed is also in this direction, which is also going to be positive. So it means that both speed, that is velocity and acceleration, have the same direction, and then we use the same sign to indicate their direction in this equation. So we are looking at the final velocity v squared equals my u is 0 plus 2 times 10 times 65. So v squared equals 20 times 65. That is v squared equals 1300. And then my v, take square root of both sides. V equals square root of 1300, which gives me roughly 36.0 meter per second. So that gives us the final velocity of the uh, ball. And with this, the assumption we made is that we ignored the effect of air resistance. And this speed is the greatest speed because the speed just before it strikes the ground is the greatest in the case when the stone falls vertically downwards. Now we take a second question. We're going to go through about three different questions in this video. Now the second question, we have a stone is thrown upwards from the ground with an initial velocity of 40 meters per second. Find the total time spent by the ball in the air. Solution: a stone is thrown upwards from the ground. That is, if I want to demonstrate that, I have this stone thrown upwards, which means the velocity is upward. The initial velocity is upward because the stone is moving in that direction. So I'm going to give upward direction this time as positive, and I want to give my G negative because G is always acting vertically downwards. Okay, so a stone is thrown upward from the ground with an initial speed of 40 meters per second. That's the initial speed. And then say find the total time spent by the ball in the air. Total time, that is time taken for the ball to rise like this, reaches its maximum height, and then to fall back to the ground, back to the same point where it was projected from. So the total time spent by the ball is more like time of flight. Time taken to rise from here to its highest point and then fall back to the same point it was projected from. That's the time of flight. And the total displacement of the ball, remember that when an object travels or moves from one point to another and comes back to the same starting point, its total displacement is 0. So if a ball decides to start from here, moves a distance of let's say 5 meters to the left, and then getting to this point, the body decides to make a U-turn and reverse back to the same point of projection, covering a total distance of 5 meters. This direction is to the right. The direction back to the starting point O is to the left. So we see that the total displacement of this body, displacement to the right can be given positive, displacement to the left can be given negative. So that total displacement is 5 minus 5, which is 0. So when the body returns to the point where it started from. After covering some distance, the total displacement of the body is zero. So when this stone hits the ground again, the ground level from where it was projected, its displacement is taken as zero. So put S is zero here, and then what else is given there? Okay, we only have these four parameters given to us. So which equation? Okay, G, we have to put down G, that is 10 meters per second squared. That's important that we include that. Now to solve this, we invoke equation 2, that is S equals ut plus half at squared. If I want to modify this equation to suit this problem, I have to take my a as minus g because of the direction of g. G is acting down, was already used positive for upward direction. That's the initial speed. That's a positive direction. My g, which acts downward, will be given a negative direction. So that gives me s equals ut minus half gt squared. By the time I replace a with minus g, I want to replace a with minus g, that gives me half gt squared. So let me move to this part of the paper and then go on to write s for 0 equals my u is 40. So 40 times t, that is ut, minus half times g is 10, times my time t, that is t squared. That gives me 0 equals 40t minus, this is 5, that is 2 here, that is 5, 5t squared. Now I need to bring 40t to the left hand side of the equation. That gives me minus 40t is equal to minus 5t squared. Dividing both sides by 5, that will give me t squared is equal to 8. So that to find the time, I'll take the square root of 8. To find the time, I have to quickly take the square root of 8, and that gives me 2.82 seconds. So it takes 2.82 seconds for the stone to go from the point of projection and then back to the same point on the same plane of projection. 2.82 seconds. Okay, quickly we'll look at one last question before I round off today. The last question, question 3, we have a cannonball shot vertically upwards reaches a maximum height of 80 meters above the ground level. The question says we should calculate the total time taken rather to reach the maximum height and the speed of the ball when it was shot. Now we need to quickly look at this question. I'm supposed to even show you two different ways or methods of solving this question. Number one, you can decide to calculate the speed of the ball first before now find the time taken to reach the maximum height. So for the solution, okay, let's do that one first. Shot vertically upwards reaches a maximum height. The initial speed is not given because for it to even go up to start with, it needs an initial velocity that is not given. The maximum height attained by the ball, the cannonball, is 80 meters. And then we are given g as 10 meters per second squared. Okay, let's first of all find the initial speed of this body. And again, when this cannonball is shot upwards, I told you in the other video, I explained that when the body is fired vertically upwards, on reaching its maximum height, the final velocity of the body goes to 0 at its maximum height. So must include that. Most questions will not even give you that information. The examiner expects you to know that when a body is projected in this fashion, at its maximum height, its final velocity is 0. So what equation we go here? Is equation 1, is equation 2, equation 3. I want to guess the equation. The way I'm looking at it, we need the third equation of motion. If I want to find the speed of projection first, I need v squared equals u squared plus 2as. Now I need to modify this equation. The body is projected vertically upwards. The initial speed is acting in the upward direction. I can give that positive. Okay, so that acceleration G will be given negative because that one is always acting vertically downwards. So that this can be written as v squared equals u squared minus 2gs. S can be replaced with h, the height of the body, the height of the cannonball. So making my substitution, I have my v squared is 0 at maximum height. That 0 squared equals u squared minus 2 times 10 times 80. That gives me minus u squared. By the time I take my u to the other side of the equation, it gives me minus 220 times 80. Okay, that gives me minus u squared is equal to minus 1600. So negative cancel negative, my u equals square root of 1600. That gives me 40 meters per second. That gives the initial speed of projection of the cannonball. Now, the time taken to reach this maximum height, we can now recall equation 1, v equals u plus at, but I can write it as gt because again, I'm still taking the acceleration direction as a negative because it's acting downwards. So at maximum height again, v equals 0 when the ball gets to its maximum height. So this gives me 0 equals 40 minus 10 times t. So that gives me minus 40 equals to minus 10t. So negative cancel negative. So dividing both sides by 10, the time taken is 4.0 seconds. Okay, so thank you for watching.